And now we are going to have the talk of Fernanda.
So I thought I'd switch with Vincent just to keep it interesting. And I'll try to keep it short as well. Matthew is saying I should say I had to go out to deal with a great vision, but I just needed water, really. Okay, so I liked Vincent's last message, keep it simple, because our program is all about keeping it simple, really. And what we are dealing with here, or what I want to talk to you about today, is reducing lodging. And you will know what lodging is, plants on the ground. Important areas of wheat in the world lodge, not only under high inputs, sometimes because you sow a crop that's left a lot of nitrogen and water in the profile. It's not exclusive to wheat only. Canola, sorghum, barley, maize, rice, lodge. And it is important because it happens in good seasons where farmers can really make money. So you can, I'm not going to say much about how you actually phenotype lodging itself, but you can see from the images that it can be done from an aerial platform. We do cover an extensive range of trials, a transect of about 1,500 Ks, and when we started the project, we didn't have that ability, so we do a visual score, and we use a formula that integrates the area lodge and the angle of lodging to describe it. Lodging is, I think, one of the most important traits, other than yield, obviously, because it makes all the other traits shine. All the effort you put on the other traits, when a crop lodges, you lose yield, there's shattering, you lose quality, there can be pre-harvest sprouting, and farmers actually lose money with increased cost of fuel in the harvest and lost time, which they cannot be, they cannot be somewhere else doing something else. So this project was actually initiated by farmers that felt the breeders needed a little bit of help with delivering lines with greater standability. So it's essentially a pre-breeding project with very, very simple objectives. We really want to go from what we have now, that's this, to that, okay? So that's a well-known Australian parent. This is one of the donors we've identified, which is actually taller than the Australian parent. So it started as a pre-breeding activity, evaluating lots of lines across 4 locations, as I said, in a 15K transect. So there's lots of multi-environment trials. From those, we were able to select 15 donors that had outstanding yield and low lodging, but they also differed in some of the physiological traits that I'm going to talk about in a minute. And from that, we've done lots of crossings to 3 Australian parents, and we are currently growing 12 populations in the field. So you can ask me about the project. It's got many sites later on, but I'm going to focus on the phenotyping challenges now. So for us, it was all about assessing the robustness of the traits that people have already worked on and seeing if they worked for us, and establishing the relationship of those traits with yield. And that's really important because you don't really want any trade-offs here. And where we could improve or develop appropriate methods for those traits to facilitate screening, particularly in early generations where the enrichment can happen, but also for gene discovery because the project has a marker discovery component. And to start with, I think the best I can help you with to understand lodging and how complex it is to go back to the theoretical framework of Pete Berry and colleagues, where there's a model to predict lodging actually, and main factors from the weather are wind, of course, and soil strength as influenced by water content. And you can sort of have 2 categories of lodging, stem lodging or root lodging here. In the case of stem lodging, stem strength the anatomy, the material strength, which is of course influenced by the composition, have a lot to do with it. Whereas in the case of root lodging, it's more all about root anchorage and root properties. And in the middle here, plant or shoot leverage is crucial actually. So this movement, the swaying in the wind, the weight of the spike, which we're all the time trying to make heavier, have a great importance. So the list behind, below each of those boxes is the number of traits you need to measure to get to know something about it. And it's quite extensive. And one of my goals is to make it, practical and short. And in black, you can see some of the calculations we do for the model. The procedure here that we followed, as established, was to harvest plants during grain filling about early or mid-down stage, and from there assess all these characteristics. And this is the time where plants lodge, obviously, or more likely. So stems, I will talk about stems, roots, and leverage. Stems are really the piece of cake part. So you harvest, you can isolate, you have to decide on an internal you want to evaluate, you measure length, dry weight, diameter. It's just a matter of cutting and scanning and some image processing. Then with one of these force recorders, you can assess material strength with very high throughput. And if you want to, you can go into composition. And composition has been a great area of discovery, particularly in rice, and we haven't explored it in wheat, but obviously lignins and other non-soluble fibers have a great role in conferring that material strength. So NIR techniques could be used to make that high throughput. I'll say a little bit more about the roots, because I think in our case are far more important. And I've self-labeled us Trident-omics, because we don't use shovels. We work in soils that are very heavy, vertisols, and we had to, you use a shovel, you compact everything, it's a mess, you create holes of water, it just doesn't work. So we modified garden forks and to make them a little bit thinner, and that's what we use. And we can do, in a very laid-back Queensland Australian style, we do 2 people, 200 extractions in the morning, and then you have lunch, they are washing in the meantime, come back in the afternoon, and then we take the measurements. We haven't imaged them so far. I think we should move on to that step now. But anyway, we just have to take some dimensions that are the following. We need to know something about the root plate width in 2 directions, perpendicular. One is normally wider than the other one. We need to learn the depth of that crown root width, and I think the imaging could really help us standardize all this. And below you see the great diversity of some of the Australian materials, and a triticale just for bonus, because we benchmark the trials with other species as well. So the root plate spreads turn out to be one of the traits that consistently over time came as important for lodging. And you can see here we had about 40 lines. I've deducted barleys and triticales and all the rest for this. 2 completely different years in terms of lodging. That's the average lodging score against the root plate spread. There's a negative relationship. Now, the root plate spread and depth and the volume you can calculate with that, which is like a cone, and the weight of that crown are quite related. They have a genetic correlation. So you could really pick one for selection. And you can see here in the graph below, the root cone volume against the root plate weight. They are quite associated, which is a positive. But of course, we sometimes want to do these things off-season, so I sort of felt the duty to explore controlled environment methods, and we've used PVC tubes and the basket method. I don't know if you're familiar with it. It's been used in rice to determine root angle. you simply count the number of nodules that are emerging from there. We let the plants grow a fair bit, almost close to anthesis actually, because obviously nodal roots reach their full development later than seminal roots. And this is sort of the you can extract lots of information, but that's the top of the basket, that's the fifth slot or last, that's angles, and here we have, different genotypes. This is a transform scale, so, 20, 12, number of nodules. Now, the number of nodules turned out not to be so important here, although there are significant differences between genotypes. It's more the genetic correlation between the percentage of nodules at this stage here and this depth is negative, and that's important. That's telling us something, and we can differentiate genotypes in using that relationship. Something else we found out was that the nodal and seminal root numbers are moderately and negatively correlated, which might not be necessarily a good thing. But all this is important if it bears any relationship with the field tests. And so we've got here 1 year where the field crown volume was related to the percentage of nodules in the fifth angle category. Not too bad, genetic correlation sort of there. If we can see that it's repeatable, it might be a good test to manage large numbers of season, that then, you take a smaller number to the field to continue with the Trident-omics. So the genetic correlation varies per year, but, we're still exploring this area. But of course you always want to know a little bit more about what's going on, and when you are out there in these clay soils, it's impossible to believe that the 10 first centimeters really do anything for holding a plant, because it's like butter. All right, so we had this idea that perhaps what was happening is that these characteristics at the top were telling us something really about what's going on a little bit more underneath. So we complemented the pull-up with coring. So coring in the row, coring in the interrow, and here is an example of two genotypes that have a significantly different plate spread and depth. And when you look at root length in the row, they just don't differ, all right? But when you look below 10 centimeters, they seem to. We have a lot more genotypes to analyze, but I think that's the trend. So the network or matrix, it's important for anchorage. I have 2 more slides about leverage. So in the case of leverage, there's also a number of measurements that the model needs: plant height, natural frequency, etc. You can do all those in the lab or in the field. They are relatively high throughput. But what I really like to do, and this year we've concentrated a lot on doing lots of LiDAR measurements, because you can derive the height, and also I want to explore the idea of getting a canopy porosity parameter that may help us to replace all these onerous or time-consuming tasks that we are doing for leverage. And the last one is something that we've started trying this year, an example we've taken from our RISE colleagues, which is the Bush Probe. Very cheap instrument. You can see it, this has been published, how you do it. RISE is, of course, a little bit different. We had to adapt it to our rows, but we simply have, the probe and a way of telling where we are at 45 degrees, and we can detect nice difference between genotypes that have been proven also with the force recorder. We know this one has higher material strength, and incidentally higher root plate. So I'm sort of a non-believer in the root and stem lodging dichotomy, actually. But, I got to prove it further. So conclusions, we've found genetic variation for high yield with low lodging, with some of these physiological traits being now captured in crosses with adapted parents. Multi-trait analysis, without including the leverage component, I must say, so far, has shown that stem characteristics show up as important in some years, but the root ones are consistently there with rankings that are stable. And we have some promising ideas and results about other tools that could actually be used in the field and help us get rid of so many parameters that we need to measure in the model. So my last message is that because we are always trying to increase yield potential, the trait boundaries for these parameters of lodging are really a moving target. And nobody should forget that it takes biomass to make a plant stronger. I show the relationship between the root plate spread and the biomass in the root. So let's keep that in mind when we think about biomass. Some of it needs to go down there. And that's all for me.
Okay, I think that we have time for one question, one quick one, before the coffee break.
Fernanda, very nice talk. Thank you very much. So lodging doesn't happen every time, right? So what is the cost that the plant has to undergo? Like if you have lodging resistance, does under favorable years, does it has a disadvantage in terms of yield potential?
Okay. I think you could think about in these two ways. When you breed lines, and Greg, who's here, and he's part of the team, together with Lynn McIntyre, Tony Condon, and all these people that have helped in this work, can correct me, but these lines of high yield potential are not the lines that you would perhaps target to a typical area where you're going to get 2 tons. So it's something naturally for enrichment for those areas where you're going to have our particular target or mission was above 7 tons. Okay, now we are talking 10 to 13. So it's not, for a low yield environment, I suppose.
Okay, I think there's one more question. Okay,
it's just more a comment. That's really nice, Fernanda. I don't know if I've seen combining the crown root measures with the coring, and it's a really nice example of how both provide different information. Thank you.
So please join me again in thanking Fernanda for a very interesting talk.